Hello. Well, this live stream may not have my. I'm gonna not talking in about an hours, maybe. Yes, no commentary. Sometime I'm gonna say something. Well, and most of the time I'm gonna spend. Wait, what the heck? Cannot. Oh, dang. I cannot even do sing like. Okay, good. Maybe just do this. Oh, oh, right. Um, let's see, project. Good. I'm gonna find some rush chords. And I think that the free code cam is the best for this. 13 hours for rush.
What in tar?
Welcome to this Rust programming course for beginners. This comprehensive course will guide you step by step through the fundamentals of Rust, enabling you to build robust and efficient applications. From understanding basic syntax and data types, to exploring more advanced topics like lifetimes and closures, Arfan Zubi will provide clear explanations and hands-on exercises to ensure you grasp every concept effectively. Get ready to unlock the power of Rust and elevate your programming skills to new heights.
Yeah.
Hi, my name is Erfan and I will be your guide in this comprehensive Rust course for beginners. So if you're interested in learning Rust, then congratulations, you have found the right course. So I've designed this course to ensure that you will learn Rust the proper way, using slides and visuals to illustrate concepts and providing exercises we will solve together. This means you will have an appropriate mix of theory and practice that will help you step by step mastering this new awesome programming language. And I strongly advise you to go along because you will learn so much more when actively participating rather than just watching the video. So let's dive in. So what are the goals of this course? First and foremost, getting familiar with core concepts and syntax of the language. We will take a look at data types and data structures, as well as ownership and borrowing. We'll see how data is allocated in memory and how we access the data. And we'll take a look at standard library, generics, traits, lifetimes, and much, much more. Basically everything you need to become a great Rust developer. So why would you want to learn Rust? Now there would be, I guess, 1,000 reasons, but I've here put together some of the main ones. Now Rust is a really fast language in terms of execution time. It provides a rich type system. It doesn't have a garbage collector, which is part of the reason why it's so fast. It provides useful compiler outputs, and you will see that in the exercises we are solving. It guarantees memory safety, and it's the most beloved programming language since 2016 according to Stack Overflow, meaning now 7 years in a row. And we are experiencing fast adoption in various branches. Now over here you can see a table which shows various programming languages and their score in terms of energy efficiency and execution time. And as you can see, Rust is one of the languages on the top of the list. Now over here are some resources that you can learn with. Now I guess the main resource would be the Rust programming language. Really fantastic book, and I recommend you to read it. Then there is Rustlinks. These are small exercises, basically programs which you have to debug. Then there is Rust by example. So if your style is more focusing code and less on text, then this would be suitable for you. And there is a website called Rust by Practice, and that is what we will cover together. And if you want to go more advanced, there is a book called Rust Forestations, and it's also very much recommended to read that. So before we dive into the first topic, I want to show you the website of Rust by Practice. And you can access it by going to the URL practice.rs. And this is the website. And over here, as you can see, these are all the topics we will cover together. Right? Now, this will be the first one, variables. And as you can see over here, we have small exercises that we will solve together. Now, before we start,
Wait, hold on. Thai Rust by practice. Oh my god. We already have one. Yes, we already have one. Okay, good. Now, the variables, binding. Let me see. Oh damn! What the heck is this? Nah, I'm gonna watch the videos.
I want to show you something else, and of course we'll keep up with the tradition and write a Hello World program. So you can go to the rustlang.org website. This is the official website of the Rust Foundation, and you can click over here, Playground. And as you can see over here, you can write Rust code and then execute it. And it's really cool because you even have the Vim key bindings over here, and you can even choose themes like that. And let's write our first program. So every program in Rust starts in the main function. This is the starting point of execution of every Rust program. And we declare functions with the fn keyword. So to print out to standard output, we can use the print line macro. As you can see, we write print ln exclamation mark, and then we can provide here the string we want to output. Like that. And then you can hit run. And as you can see, we have executed our first program. So congratulations, I hope you coded along, and now we start with the actual course. So variables. Variables are assigned using the let keyword. So if you're coming from a JavaScript background, this might seem familiar. You can print to standard output by the print or print ln macros. So print and print ln are basically very much the same, but print ln adds a new line at the end of the output. And scope of a variable is defined by the block of code in which it is declared. Now a function is a named block of code that is reusable, and shadowing allows a variable to be redeclared. In the same scope with the same name. So let's solve some exercises. Binding and mutability. A variable can be used only if it has been initialized. Fix the error below with least amount of modification to the code. So again, we are starting always in the main function. Now over here we have two variables. And again, we declare variables with the let keyword, then the name, and over here we have a type annotation. Now, don't worry too much for now, we'll cover that in the next topic to come, but for now, think of i32 as an integer type, right? And then we have here the assert eq macro, which stands for assert equality. So this macro takes two arguments and just basically asserts that these two are equal. In case they are not equal, the program will panic, meaning immediate exiting and returning an error message. If they are in fact equal, then the program will just continue executing. So as you can see, we want here that x is equal to a value of 5. So we can initialize x over here with a value of 5, like that. And to run this program, you can either click here or you can press Ctrl Enter. And let's read that over here, uninitialized but used error. So when you use a variable, it has to be initialized with a value, which makes sense, right? You can't use something which isn't initialized yet. Now y over here is uninitialized but also unused. This will only output a warning. Now over here you can see the warning actually, but if I take this code and put it over here, as you can see, it gives us a warning, unused variable y. Okay? To fix that, we can prepend it with an underscore, like that. Alright? Use mute to mark a variable as mutable. So in Rust, a variable in its nature is immutable, and you have to explicitly state that you want a variable to be mutable. So fill the blanks in the code to make it compile. As you can see, we are here using a variable x, so we want over here to declare x and initialize it with a value of 1. Now over here we are mutating x, which means this variable x over here should be mutable, and we do that using the mute keyword, like that. Now this over here is shorthand syntax for this. Alright, so we take the value of 1, we add 2 to it, and then we assign it back to x, meaning x will then hold 3, right? Now, just a quick note, I will always try to annotate the type in this course. Most of the time it's not necessary, so when you see me annotating types, it's actually not because this is necessary, but just because I want to make stuff as clear as possible. So in this case, this would hold an integer type, and again we'll cover that in the next topic. Let's see. As you can see, this is compiling, x is equal to 3. Scope. A scope is the range within the program for which the item is valid. Fix the error below with least amount of modification. So over here we are initializing the variable x with a value of 10, an integer type. Alright? Now here we have another scope. We also can call it the inner scope, and this would be the outer scope. Right? So in this scope over here we are declaring another variable, y. Now we over here try to print out x and y, and we can do that by placing inside the println macro these placeholders over here, and then providing as additional arguments over here the variables we want to put the values inside here. So for example, if we provide x over here, then this will get replaced by 10, because x is holding a value of 10. And as you can see, in the outer scope we are doing exactly the same. Now this program won't compile, and the reason is because a variable is only valid inside the scope in which it was declared. So for example, the variable y is declared inside the scope, meaning the variable y is only valid until this point. Alright? That means we can't use y here. So what would be the solution? The solution would be very simple. We just initialize the variable y in the main scope, in the outer scope over here, meaning x and y, both of them are valid until this point over here, right? Because this over here is the main scope. Let's see. As you can see, this is compiling.
Seriously, I got the x here, the y here, and no x. I cannot really use this x. There we are.
Fix the error with the use of define x. Now we can have other functions besides main. So over here we have the function define x, and as you can see we are initializing a variable x which holds a string. Now this would be the type annotation for a string, right? Don't worry too much about the annotations now, because we will cover that, but just to let you know. Now the problem here is that in main we are trying to access x. Now in this scope over here there is no variable with the name of x, which means that this program won't compile, because the compiler will tell you I can't find over here a variable with the name of x. So what we can do over here is actually taking this line and putting it inside the function over here, because as you can see in this scope of the function, a variable x has been declared and initialized. But if I run this program now, nothing will happen. And that's because, as I've said, the starting point of every Rust program is in the main function. Now when we run the code, nothing will get executed, and that's because we have to actually call this function for it to do something. So in this case we can call a function like that, just providing the name of the function and these parentheses. And as you can see, the output will be hello world, right? Because over here we are providing x to the print line macro, and we are appending to it comma world, like that.
What if you could create AI characters that remember, empathize, and
Sharing. Well, only modify the insert to make the print line words, the print 42 tones, search is x, and this one print straight 42. Thank you. And two expressions equal to each other using particularity. Insertion only check both debug and release view and cannot be disabled. Unpanic. This macro will print the value and fraction with their representation like assert. Second formula of custom panic message can be provided.
Shadowing. You can declare a new variable with the same name as a previous variable. Here we can say the first one is shadowed by the second one. Only modify assert EQ to make printline work, print 42 in terminal. As you can see over here, we are initializing the variable x, which holds an i32 type, an integer type. Now in this scope over here, we are initializing another variable with the same name, x. But over here, we are initializing it with a value of 12 instead of 5. And that means when we assert the value of x over here, it should actually be 12, right?
Oh.
Now what would be
Oh, wait, means 12. And it's 12 also.
the value of x in this outer scope? If you said 5, then you're right, because this variable over here has been declared in the main scope, in this scope over here. That means x is holding a value of 5. Now in this scope over here, x holds a value of 12. And these are basically two different worlds, right? So the variable x declared in the main scope doesn't actually care about the variable x declared in this scope over here. They are separate. Now over here, we are shadowing x in the main scope, meaning we redeclare and reinitialize the variable x, again with an integer type. Now when we output x, it should actually print out 42.
Scope. So,
As you can see, this will be the output. Number 6, remove a line in the code to make it compile. Now over here we have a mutable variable x, which holds 1, an integer type. Then we are assigning 7 to x. Now x holds 7, right? Then we are shadowing and rebinding, so we are redeclaring x and reinitializing it. And we initialize it with a value of x, meaning with 7, right? And then over here we are mutating x, and that means we are here incrementing x by 3. Again, using this shorthand notation, which would equate to that. And this would actually fail. And I want you to look at it and think about it. What over here might cause an error? So over here, as you can see, we are redeclaring x. And over here, we are mutating x. Now, as I've said, every variable in Rust is in its nature immutable, meaning if we redeclare x like that, x will be immutable. Even if it was mutable over here, when we shadow it, then it will be immutable again. So what we can do over here is just using the mute keyword again, so x stays mutable. Now, you might ask, okay, why even shadowing? We can just assign a new value to x. Why is this even a thing? And you can see that here very good. So y over here holds an integer type, right? An integer 4. Now when shadowing, we can assign to the variable a value of another type. In this case, for example, a string, right? So y will then hold a string type. Right, let's run that. And as you can see, this compiles. Now this line over here is completely useless. I hope you noticed that, because we are taking x and assign it again to x, which basically is the exact same thing as we had over here. So completely useless. Of course, they are doing that to learn the concept, but in real life, you don't need this line. All right, you can just do it like that. And as you can see, this also compiles. Unused variables. Fix the warning below with only one solution, 2 distinct solutions. So as you can see, of course, we want 2 stars, so we will do with 2 solutions. Now the problem here is that this program won't actually output warnings, right? So I will again copy that, and I will put it inside the Rust playground, like that. So if we run this program now, as you can see, we get a warning, unused variable x. Now I have showed you that before. The easiest method would be to prepend the variable name with an underscore. As you can see, we don't get the warning over here. The second way would be to do it like that. This is telling the compiler that it should allow unused variables. So if you run it again, As you can see, no warning.
Getting started is easy. Upload your documents, secure them, and then share them with third parties.
So we have solved that. Destructuring. We can use pattern with let to destructure a tuple to separate variables. Now, tuples, we'll cover that in a later topic, but for now, just think of tuples as a data structure that can hold various values, even of different types. So fix the error below with least amount of modification. So as you can see over here, we have a tuple, right, holding two integers, 1 and 2. And this over here is called destructuring. So we are using the let keyword, and we use this syntax over here to destructure these values into variables x and y. So x will then hold a value of 1 and y will hold a value of 2. Now over here we are mutating x. Now again, this variable here would be immutable because in Rust every variable in its nature is immutable, and we have to explicitly state that we want to have it mutable. So what we can do over here, like we did before, we use the mute keyword like that, and then this should actually compile. So x holds 1 here, and then we increment x by 2. So x should in the end hold 3 and y should stay the same as it was.
Wait a minute. Why must add the mod here? Wait, hold on. We assign the x and a y for multiples anywhere by a value to the variable name. The secondly can create variable unique. No other variable can have a multiple reference nor a shared reference. Very good. Topple, slide, struct pad, left hand. So code work.
And as you can see, this is compiling. Destructuring assignments introduced in Rust 1.59. You can now use tuple, slice, and struct patterns as the left-hand side of an assignment. So this is very useful actually. So we can declare two variables at once. So here we declare x and y, and this would be the same like writing let x and let y, right? So you're writing one line of code instead of two lines here. Now again, we declare here the variables, and we can then destructure these data structures over here. So we have here a tuple, and we are destructuring it. And notice over here, we don't need to use the let keyword again because we have already declared these variables over here, right? So we assign 3 to x, and this value over here we don't care about. So we can use these double dots over here. Now this over here is an array, and again we will cover that, don't worry. And this array holds two values. Now we don't care about the first one, but we want to destructure the second one into a variable called y. Now fill the blank to make the code work. In this case, we have here an array, right? Remember, assert eq takes two arguments, and both of them have to be the same, equate to the same output, right? So what would be the value of x? It would be 3, because we have destructured here 3 into the variable x. And the same goes for here. We have destructured 2 into a variable y, which means y will then hold 2. All right, and we are done with the first topic. Easy start, and see you next time.